In this screencast, we will analyze a more complicated block diagram which contains multiple loops and also multiple input variables. So in our case here, what we're trying to do is see how the output variable C is affected by two input variables, R and L. When faced with a block diagram with multiple loops, the best strategy is to focus on your innermost loop first and then work yourself from the inside out. So in this case here, we're going to focus on the innermost loop, which is being currently boxed in. To make our lives easier, we're going to define a variable coming into this box and coming out of this box. We'll define the input coming in as x and the output coming in as y. Our goal here is to condense what is inside of our block diagram such that we have y as a function of x and L. The first goal here is to find the transfer functions y over x and y over L. So to complete this, recognize the fact that at a branch point, which is what we see here, the variables are identical. So therefore, before the branch point, we have a y, and then at the end of the branch point, we have a y. If we move from left to right and we start at our summing point, which is right here, what will come out of that summing point is the sum of x with a positive sign minus y multiplied by G3. So next we want to do is proceed through the GC2 G1 blocks. And since the blocks are multiplicative, we just multiply GC2 times GC1 by both terms. So we end up with GC2 G1x minus GC2 G1 G3 times y. After going through these blocks, that leaves us right here, as indicated by the star on the block diagram. So what we now need to do is go through the summing point. Once we go through the summing point, that sum will be shown to equal y. So if we go through our second summing point, we see the fact that we have two plus signs, and that will leave us with the term that we started with, and now we sum in our L term, which will just be L multiplied by G2. This all together will equal y. So now we're going to find the transfer functions. To find the transfer functions, we gather like terms together. The left-hand side will remain the same. Once we complete our next step, just to factor out y. And when we divide both sides by the 1 plus term, we end up with a couple transfer functions. This transfer function is the transfer function y over x, and this transfer function represents y over L. What we'll now do is redraw our block diagram to show what this compression has done. Now we will use the exact same method as we did before in order to determine the transfer functions, which were C over R and C over L. So to do this, starting the exact same way, moving from left to right with our summing point, which is right here. So with that summing point, we once again have the branch point here, which shows where everything there is C. Coming out of this block will be C times G5. So our first summing point will be R minus C times G5. We can then go through both the GC1 box and the combined box. Here, x is no longer necessary because x would just be defined as our summing point multiplied by GC1, so x and y we no longer need anymore in our analysis. After you progress through the two blocks, you end up with R minus CG5 multiplied by the terms multiplied together, GC1 and then GC2G1 divided by 1 plus GC2 G1 G3. Next, we go to our second summing point, and our second summing point will be the messy term that we have here plus L multiplied by G2 divided by 1 plus GC2 G1 G3. The box that's right here at the top of our diagram. Finally, we'll progress through the G4 block. And really all we're going to do here is multiply all of our terms that we've developed at the second summing point by G4. And the important point here is the fact that this, if we look up at our diagram here coming out of the G4, will equal C. So what we'll now do is write all of these terms out and develop our transfer functions that relate both R and L to our output variable C. As you might be able to tell by looking at some of the terms we have here, a little bit of algebra will have to be utilized. So our next step here is to move the C terms all onto one side. And when we do that, what we're left with is GC1, G2, G1, G4 divided by our denominator. The L term doesn't change. And then we'll have C, the minus sign shown here, will become a plus. So we'll have plus GC1, GC2, G1, G4, G5 divided by our denominator multiplied by C. So our left-hand side is going to remain the same for now because we're going to manipulate the right-hand side. So first we'll factor out the C term. Our next step, which will make our mathematical lives a little easier in the end, is we're going to find a least common denominator for this term inside the parenthesis. Why? Because if you know all that the denominator of the R term and the L term both have the same denominator, so therefore we'll get some cancellation. Now every term has the same denominator, so therefore we can just cross them all out. Finally, we can get our transfer functions by dividing the term that's in the parenthesis with the C and move them to the denominators of the R and the L side. And these are our final two transfer functions. This first transfer function is a transfer function that shows how a change in the input R affects the output C. And our second transfer function represents how a change in our input variable L will affect our output C. So the important take-home point for this is when we're trying to do block diagram algebra for systems which have multiple loops in them, the best plan of attack is to work from the inside out. As you become more comfortable with doing this, you may not need to redraw the diagram, but as you're starting out, it's a useful tool to physically grasp what we are trying to do here from both the block standpoint and from the mathematical standpoint.